1452, 1453, 1454. Oh, hi.
What are you doing?
Counting
What number are you going to stop at?
at infinity.
What? Counting to infinity? But that's absurd. It would take an infinite amount of time to count to infinity. In other words, you would never even get to infinity.
Well, who said I couldn't get there?
Math did.
Did it really?
What?
Let me show you how to count to infinity. First, of course, at t equals 0, you count to 0. And then, after half a minute, you count to 1.
Half a minute? Isn't that a long time?
Be patient. Just bear with me really fast. Then, a quarter of a minute after that, count to 2. Then an eighth of a minute after that, count to 3. Then a 16th of a minute after that, count to 4. Then,
I think I see where you're going here. Every time you're having the time it takes to get to the next number, and since you can have a number as many times as you like,
after 1 minute, you will have counted to infinity.
but as the counting rate gets faster and faster, you have to count quicker and quicker, and eventually you get to a point where you're breaking the laws of physics because you're counting so quickly.
Well, yes, I must admit, that is true. But still, this is a neat thing to think about, isn't it?
Well, I guess.
This kind of thing, doing an infinite amount of things in a finite amount of time, is called doing a super task. See, it even has a cool name. Counting to infinity quickly isn't the only super task, though. There are plenty of other examples.
Like what?
Like Thomson's lamp, a thought experiment by James F. Thomson. Imagine that you have a lamp. It begins off. After half a minute, you turn it on. A quarter of a minute after that, you turn it back off. And an eighth of a minute after that, well, you get the idea. The question is, after 1 minute, is the lamp on or off?
Well, after 1 minute, it can't be on, because each time it's turned on, it gets turned off shortly after. But it can't be off either, because after it's been turned off, it's been turned on again. So it can't be either.
But it has to be one of them. See, it's a paradox.
Well, but does this all even make sense? Maybe you just need more information to tell what will happen. For example, maybe just saying what you said isn't enough information, but if the switch is a switch that is retracted towards off, then the lamp will be off after 1 minute, and vice versa. Just an ordinary switch doesn't give enough information about the behavior of the lamp.
Well, sure, I guess. But there are also other, even weirder things in the realm of supertasks. Take the Zeno machine, also known as the accelerated Turing machine, also known as the ATM.
An ATM?
Yes, the ATM is another supertask, except unlike the others, it's a computer. After half a minute, it does one computation. A quarter of a minute after that, it does another computation, and so on. Every supertask I have talked about can be converted into a computer program in the ATM. The counting to infinity can be a computer program that increments a certain variable, and the Thomson's lamp can be a program that toggles between two states. But here's the really interesting thing. Because of its infinitely fast computing abilities, it can check every single integer in just a minute. So that means using the ATM, you can prove or disprove any conjecture over the integers very quickly. For example, you can easily and efficiently prove the twin prime conjecture, the Collatz conjecture, or pretty much any conjecture over the integers with an ATM.
Whoa.
I know, right? And you can even make and run a program on the ATM that calculates the digits of pi. So technically, after 1 minute, you could have the last digits of pi in your hands, which is so cool.
What? That's pretty confusing. Infinite things like pi are supposed to have no end, but you're saying that you can find the last element in them using an ATM?
Well, yes, but these machines and supertasks are anything but possible. Sadly, the laws of physics strictly prohibit them. So all we can do is think about them and speculate what it really would be like to do a super task.